Hello guys. So today I will be discussing the second problem of biweekly contest 99 held in lead code. Okay. So we have to count the total number of colored cells. Okay. So let's read the problem. There exists an infinitely large two-dimensional grid of uncolored unit cells. Okay. So presently there are infinite grids. Okay. So a grid is like a square or a chessboard. Okay. So the chessboard containing only white colors. Okay. So you are given a positive integer n indicating that you must do the following routine for n minutes. Okay. So until and unless n minutes are passed, we have to do the following things. At the first minute, color any arbitrary unit cell blue. So as you can see, this n equal to 1 depicts the first minute. Okay. So we have to color any cell blue, and every minute thereafter color blue every uncolored cell that touches a blue cell. Below is the pictorial representation of the state grid after 1 minutes 1 to 3. So at the second minute, as you can see, the number of edges in this square is 4, or adjacents is 4. So we have to color the next square that is present in the very adjacent. So as you can see, total number of squares present in this figure is 5. As you can see here, that I have colored the squares present adjacent to the square. I will explain more clearly in my board. And in the third case, after coloring all the adjacent in this figure, we have this, the result figure is this. Okay. So what we have to return is the number of colored cells at the end of n minutes. So for n equal to 1, the number of colored cells is 1. For n equal to 2, the number of colored cells is 5. And for n equal to 3, the number of color cells is 13. Okay, so I have counted in my rough, and that I will show you. So let's jump to the blackboard and see what is happening. So at first of all, you have given an n equal to 1. So let's suppose this my whole space is a grid. So first I will, for n equal to 1, I will first take a square and make it a color blue. Okay. So let's suppose that the white square is depicting the color blue. Okay, so for convenience, now depicting the figure n equal to 2, the number of adjacents present here is one, this and this. So after coloring the squares present in this figure, we will get a figure like this. Okay, so and let's suppose, okay, and let's suppose we want to calculate now for n equal to 3. Okay, so n equal to 3, so what will be my diagram? So diagram initially was like this, and this. Okay, now what are the adjacent? Okay, so we have to add squares for the adjacent. Okay, so what are the adjacents? So this is one adjacent, this is another adjacent. Okay, it covers two sides. This is another adjacent, and this is another adjacent. And also we have to cover these adjacents. Okay, these adjacents. Okay, now for the last time, I am going to, for another example, I will fill up, or I will draw the figure. So let's make it quite fast. So this is my square, this is my another gus, and with the help of blue I will draw. So this is the figure for n equal to 3. So now when n equal to 4, we have to cover this adjacent, 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 and this adjacent, and also we have to cover. Let's suppose this adjacent is covered, this adjacent is covered, this adjacent is covered, and this adjacent is covered. Now what we have to return finally? Finally, we have to return the number of squares present in the figure. Okay. So in the first case, our output will be 1 as there is only one square. In the second case, output will be 5. Third case, the output will be 13 as 13 squares are there. In the fourth case, the answer will be 25. Now, how the hell these answers has come? As you can see, if you observe carefully, okay, observe carefully. In the first level, this is, let's say, but the number of square is present is 1. The second level number of square present is 3, 1, 2, 3, and in the third level the answer is the number of square present is 1. So the total, if you sum all this, the output will be 5. Okay, so in this way we are getting the answer. Okay, and in for n equal to 3, the first level number of square is 1, second level number of square is 2, in the third level number of square is 5, in the fourth level the number of square is 3. So this will be 3. Okay, I have done a mistake, and again this one. If you add this, the answer will be 13. See, 3 plus 3 9. Oh, sorry, 3 plus 3 6. Again we add 1 1, the 8, and 8 plus 5 13. Okay, and in the last case, if you see the level 1, for the level we have 1, again 3, again 5, again 7, and again 5, again 3, and again 1. So if you observe, it is actually forming a series. Okay, so now we will generalize the sum. Okay, so how you can generalize? As you can see, for n equal to 4, let's see how 25 is coming. So 1 plus 3 plus 5 plus 7 plus 1 plus 3 plus 5. If you add this will give us 9. Okay, so this will give us 9 and 7. So 9 plus 9 plus 7 is 25, no doubt. But again, let's see this case. So 1 plus 3 plus 5 plus 1 plus 3. Again 1 plus 3, this gives 4 and this gives 5. So 4 plus 4 plus 5, 13, no doubt. And for this case, 1 plus 3 plus 1. So this is giving us 5 and this is 1 as the base case. What you can observe is this 5, this 5, this 3, this 7. How we can get 5 from n? So this 5 can be getting as 2 into n minus 1. Okay, 2 into n minus, as you can see, n is 3, so 3 into 6 minus 1 will give 5, and this 7 will be given as again 2 into n minus 1. So 4 into 2 8 minus 1 is 7. Then, as you can see here, 1 plus 3 is 4. 1 plus 3, but again 1 2 plus 1. If you see it carefully, and here in this case is 1. This 1 can be written as 1 square, this 4 can be written as 2 square, and this 9 can be written as 3 square. Okay, so how this 3 can come from n? So it can come from like 3 square is, it will be equal to just n minus 1 square. This 9 can be written as n minus 1 square. So my answer is basically n minus 1, sorry. So my answer is basically n minus 1 square plus 2 into n minus 1 plus n minus 1 square. Okay, so it is actually 2 into n minus 1 square plus 2 into n minus 1. Now I will open it. Okay, so this will be 2 into n square minus 4n plus 2 plus 2 into n minus 1. This will be equal to 2n square. First will come minus 4n and plus 2n. So it will be minus 2n. Okay, minus 2n plus 1. If we take 2n common from these terms, so 2n will be equal to 2 into n minus 1 plus 1. So this will be my answer. Okay. So the whole problem is reduced to this teeny formula 2 into n minus 1 plus 1. Okay, so let's jump to code. As you can see, the answers must be written in long n. So we have to first store the n in a x variable, then return 2 into x minus 1 into x plus 1. Okay, I will check just. Okay, now let's see. So 1 answer is submit. Let's see the submit accepted. Okay, so I hope if you enjoyed the video and also you have understand the problem. If you find this video useful, please like and share the channel. Okay, so goodbye.